Hello everyone, my name is Connor Murphy and this is my Microprocessors 2 Final Demo. I created a simple 2D game based off of the Pokemon franchise that I'm calling MicroPokemon. So first, the goal, like I said, was to create a simple version of a 2D Pokemon game similar to the graphics and gameplay of Pokemon Soul Silver and Pokemon Platinum. The game has two states, a walking scene and a battle scene. The game starts in the walking scene, where if you walk in the tall grass, a battle will randomly be triggered, which will look like the scene on the right. There are three main design components. First, the TIVA microcontroller, which runs the game RTOS, which controls game logic and takes in multi-mod button and joystick inputs from the user. This TIVA microcontroller then writes over UART data to a BeagleBone Black, which loads the sprites, updates Pokemon health, and writes corresponding data to the display. This display data is written over SPI to an LCD, which again displays either the walking or the battle scene. To design the RTOS, I first created background threads. These threads include the player Pokemon thread and enemy Pokemon threads. The player Pokemon thread waits for the battle scene and player turn semaphores. When those semaphores are 1, it then reads in the user button input and performs a corresponding battle move, decrementing the enemy Pokemon's health in turn. Next, the enemy Pokemon thread will again wait for the battle scene, and this time the enemy turns semaphores, and it will generate a random amount of damage and decrements the player Pokemon health by that amount of damage. The player walk thread waits for the walk scene semaphore, so it only actually runs when you're in the walking scene, and it reads from a joystick FIFO and updates the player coordinates on the map while checking to see if you're in tall grass. If you are in tall grass, a battle scene will randomly be triggered. Finally, the check game state thread checks for a fainted Pokemon to end the battle scene. This is when the enemy or the player Pokemon health is 0, and then it handles that transition to the walking scene. Next, we have our periodic threads. The first is get joystick, which simply reads in multi-mod joystick data and writes that data to a joystick FIFO. The print data periodic thread then prints out either the Pokemon health or the player walking coordinates to the Code Composer Studio's UART terminal. This was mainly used for debugging and creating my game logic at the beginning of this project. And finally, the send packet periodic thread will periodically send a packet of 5 bytes of data over UART to the BeagleBone. This data is interpreted by the BeagleBone as either player and enemy Pokemon health or the player walking coordinates based on the 4th byte, which if 0 means you're in the walking scene and if 1 means you're in the battle scene. Finally, the only aperiodic thread is the GPIO E handler on the TIVA, which handles the multi-mod button press interrupt. If a button is pressed, it will signal the button press semaphore. These are all the semaphores I used in my RTOS design. There are simple semaphores to handle UART, I2C, and SPI control. There's also a joystick press semaphore, a button press semaphore, player turn and enemy turn, which signal which Pokemon should be attacking right now. And there's a battle scene semaphore and a walk scene semaphore, which, as I already said, are used to control which scene is drawn by the BeagleBone onto the display, either the battle scene or the walking around on the map scene. To close, my first design milestone, which I reached a few weeks ago, was to implement SPI writes to the LCD via the BeagleBoard. As you'll see in a moment in my demo, the BeagleBone had to be connected to the LCD over a bunch of jumper wires. Additionally, the TIVA and the BeagleBone had to be connected via jumper wires, so everything is implemented on a breadboard. So it took a little bit of time to get the SPI writes to the LCD working. I then implemented game mechanics, including reading in the joystick and button presses and linking that to character health or player coordinates. And finally, I implemented that UART communication between TIVA and BeagleBoard. Once I had that working, my second milestone was to draw Pokemon sprites onto the LCD through the BeagleBoard. as well as drawing Pokemon health bars and updating that health upon the button press by the user. And I then created a fully working battle scene for my semi-final demo. Finally, my milestone 3, which completes this simple Pokemon game, implemented the walking scene and random battle generation, and updated my character sprite quality to not include any of the border pixels of the 128 by 128 PNG image. And now I'll move on to a quick project demonstration of MicroPokemon running. For my final project, I created a simple Pokemon game. There's 3 main components. There's the LCD screen on the bottom, which displays the game. There's a BeagleBone Black right here, which writes over SPY to the screen and also renders the sprites and the overall game view, which is then again written over SPY to the screen. And the actual RTOS running the game behind the scenes is all running on the TIVA microcontroller, which then sends game control logic over UART to the BeagleBone, which will in turn update what it renders and write that over SPY to the display. So first, a quick demo. If you've ever played Pokemon before, you know that it begins in this walking state. The multi-mod joystick right here is used to walk around. And if you enter into the tall grass on the bottom here, a battle is randomly triggered. Here we go. And then right now, the player Pokemon is Squirtle. The enemy Pokemon is Pikachu. To perform actual moves, you can use the 4 multi-mod buttons right here. This button does -1 HP to the enemy, this one -2, this one -3, and this final one -4. So I'll go ahead and make a -4 move. There you go. You can see the sprites are slightly animated. You can tell when they're attacking and when they're taking damage. I'm just going to keep using this attack until the enemy Pikachu faints. Once the enemy faints, the walk screen will be restored and you can resume play, just like that. Now we can walk around again and oh, there you go, another random battle triggered. And this process will repeat over and over until you exit the tall grass. I'll go ahead and finish this round one more time and walk around a bit more. And there we go. And now again, we can safely walk around until we go back in the tall grass to trigger a battle. And that is my Pokemon game.